So you'll probably remember in one of the previous videos where we mounted up the electronic actuator on the VNT, which you can see there in the picture now. So that's obviously going to be what's going to be moving the vanes around inside that primary turbo versus the vac can that we had on the original engine. Now those things actually pull quite a bit of current to move those vanes around. If you imagine the actual force you need to move those when it's sort of wide open throttle is actually quite considerable to close those vanes in against the exhaust flow. So you can't really drive that straight off the back of the ECU because it just pulls too much current and you will burn out the pins on the ECU. So the way we can get around that is we're going to use one of the electronics fly-by-wire cards. So it's basically just a load of MOSFETs on a card, originally meant for running throttle butterflies for fly-by-wire, drive-by-wire as they call it. So we'll just be using it in this case to bump up the output of the ECU to be able to drive the Hella actuator, which we've got over there. Now obviously when you buy these things, much like the injector driver, it just comes as basically a circuit board. So we need to make that kind of car friendly. So we're just going to mount them in these boxes. I'm going to do the same for the injector driver, which is what you can see over here. So this is basically the magic bit that enables me to drive sort of solenoid based common rail injectors out the back of a E1280 electronic ECU. So it just takes the pulses from the ECU, which would normally drive the petrol injectors. You give it a 12 volt feed as well, and then this is what then drives the solenoids. Obviously much higher voltage and much higher current than little petrol injectors. That is also going to be mounted in a box because obviously at the minute it's just a board that's going to get wet, damp and short out and get damaged. So we need to put them inside some sealed boxes where they're safe and also where they're not going to get hurt because they're quite exposed at the minute. So I bought these little adhesive standoffs, circuit board standoffs, which I'm going to hopefully use to sort of mount that in the base of there, and then we can run the wires up to a plug on the end and put the lid on and it should be safe. I've also just bought a couple of little power LEDs just so we can mount one of those in the cover. So we'll get this mounted in that box and we'll go from there. Right, next little job here then is going to be to get this injector driver board mounted in some kind of enclosure so we can put it in the car and keep it relatively safe. So basically the driver itself is just literally a printed board with nothing to mount it in. So obviously that alone just mounted in the car is not going to last long. It's not really ideal at all. So we're going to get that mounted in this box here, and we'll probably run the wires out through the side, either through a plug or we'll leave a plug on it. We haven't quite decided on that yet. Then we'll put the lid on the top. I'll put a little power LED in the top, just so you can make sure there's power getting to it for diagnostics. Other than that, that can sit in that box and you shouldn't ever need to touch it really. So this board will basically take a pulse from the ECU, from the original injector outputs. So in a petrol application you'd have your 4 whatever plus injector outputs. This is a 4-channel driver card. You can obviously use as many as these as you have cylinders. You just connect them up. So you basically just give it 12 volt ground, your 4 inputs, and then it gives you 4 individual injector outputs for your high side on your solenoids on the common rail injectors. So you can probably just about make out on the board, if my camera will focus, they're all identical. So you've got four circuits, and obviously up this side you've got some power regulation and control and stuff. Right, so I got that all fixed down now. I've just soldered in that little LED there just so we know we've got power to that board. So I'll stick the lid back on and this can be mounted up now. Right, I'm just working on this actuator driver board now. So we've just made a 20mm hole and some screw holes in the side to take the plug that we're going to stick on there. So it's just like a little military style 6-pin plug. Well, actually it's a 7-pin, but we only need 6 of the pins. So I'm just making up some jump wires now, which we'll put onto the socket that will connect to the board itself. So we'll stick the crimps on the end of that, so that will connect to there, bring it up round, loop up round to the other connector, and it just means that I can then easily connect and disconnect these different boxes within the car if required, which makes life a lot easier. That's finished up the actuator driver thing now. So we've just got a plug on the top so we can plug that in and out, a power light. I've just wired it all up internally so I can put the lid on that now and bolt that back in the car. I've also made a note on me, I've got like a wiring diagram on the computer of what pin does what. So we've got basically power ground, and then the input from the ECU, and then the high current output. So I've just noted down what pins are what. That way it's nice and easy to work out what's going on at a later stage without having to take it all apart again and trace all the wires back. Right, we're inside the car now. So just up on the bulkhead here is where I've decided to put the main bulkhead connections for the engine loom. So I've just drilled some holes with the hole saws and then some securing holes. And we've got 3 bulkhead connections
you can see the one in my hand there, and then two more. So the two on their own are for the injectors, 2 injectors per plug. I struggled to find anything with a big enough sort of ampage rating on them for the injectors, so I've ended up having to put that on 2 separate sockets. And then the large amount of the sensors and everything, well, pretty much everything else on the engine loom will be going through this plug. And you just got a couple pins at the top, or 4 pins there with a slightly higher amp rating, which will be ideal for a few things like the pressure regulator and stuff. So I'm just going to finish off that, paint this up so it doesn't go rusty, and then I'll get those 3 connectors mounted up in the bulkhead there just to make sure it looks alright, and then we'll start connecting up. Put all the screws in, but you can just see that's basically where they're going to end up sitting, just in there, so you can get your hands in there nice and easy to hook up.
Just thought I'd show you what's going on here now. So we're just making up the injector harness at the moment. So you can see at this end I've made up the 4 injector connectors and heat shrunk and braided that. So we're just putting the connectors on now, so we've got the 2 4-pin connectors that go into those bulkhead connectors. So we just sprayed out the ends right at the end, they're twisted for the rest of the way. I'm just warming up the soldering iron now so we can solder these in. So I've got all these things. The main thing when you're doing these sorts of things is you've got to remember to slide everything up the wire before you solder the ends on. Otherwise you've got to take the whole thing apart again. So we've got the shrink that goes over the join at the end, then the flex, the heat shrink that goes all around the plug, and then we can solder and obviously the back half of the plug itself, and then you can solder the plug on. So we'll get this one soldered on and all shrunk up, and then it's basically the same on that one. And then when you finish them both, you can slide the heat shrink down over the pair of the wires and then shrink that on to seal it all up.
Right, you can see that's the injector harness. I decided to make that as a separate harness just because it's going sort of from a different area of the engine. So I've just made that into its own loom, put its own connections on, and that bit can be just installed and removed separately from the rest of the wiring loom.
So just working on the main bulkhead connector here now. So just to make life a bit easier, I'm going to basically terminate every single pin now. I'm not actually going to need all of them. It's a 54 pin connector. I'm only going to need sort of 41 or 42 I think for a minute. But once you get these fitted and it's all heat shrunk in it, if you want to then add to it, it's a complete nightmare basically because it's in and behind the dash. So we're going to put tails on every single pin, run them back the loom back to where the ECU is going to be, and then I can obviously easily add into them. So if we just label every wire which corresponds to the pin, we know what's going on then at a future date. So it's really just a case of cutting lengths of wire to whatever length you need, tinning them all, and you can just solder them one at a time, and then you can just see I'm putting heat shrinks on them as I go just to sort of protect them from each other. You need a fairly fine tooth sort of soldering iron, but you can get away with using just the typical ones on eBay, the cheap nasty ones if you want to. They do the same job, but the key is you want to just be able to drop the wire in and solder it quickly. You don't want to go applying loads of heat because the heat goes back the pin and damages the connector. So just literally pre-tin the wire, drop it on the top, and you can pretty much just touch it with a soldering iron and they'll just straight away melt and solder themselves on. And then work the heat shrink. I tend to do them one line at a time, so if you solder them all on, then push all the heat shrinks on, then you can just shrink them all at once with a heat gun. And because you've got to be careful with the heat gun, because again you can do more damage than good if you're trying to do one at a time around too many other cables. So I'm going to work my way up through here now. It's 54 pins, so it takes a minute or two, and then once we're done with that, we can get this mounted in the car and sort of bring that loom all back to one sort of central location where the ECU is going to go. Right, so you can see I've just finished soldering all those wires on there now. We've got a few different size wires because some of the pins are different sizes, they've got different amp ratings, that's why they differ. So I'm going to put a sort of heat shrink over the whole lot now just to tie everything together and kind of secure it all. And then this piece will be ready to fit up to the bulkhead, and that should be able to stay there then. Okay, so now you can just see I fitted those in the car. So the 2 connectors on the left, there's 2 injectors per connector, sorry. And then the other connector is the main bulkhead connector, which basically takes everything else from the engine bay through into the cabin, which is where all the ECU and the rest of the relays and wiring will be. Right, so the next main job here to sort out now is sort of the main battery connections and ground cables and stuff, so that the rest of the car is all connected as it needs to be. Now, the battery's in the boot as it always has been. I haven't really changed anything there, so that's as it was before. You can see in the back in the red box. We've got the main battery feed then that feeds up under the car. It's just on the floor at the moment. To the isolator switch, which is in the dash here. Well, then it goes through the bulkhead as before. I haven't actually sorted this out yet, but I've just put a new end on that cable. You can just see it lying on top of the starter in there. That's yet to be terminated. I've just now made up the cable to go between there and the alternator. So I find it easy just to make these cables up.
obviously I've just this time around I'm covering everything in sort of braid in to try and make things look a bit cleaner. So I'm going to get that one connected up, and then that should be the sort of power to everything sorted, other than the main ignition feed, which I will then run separately to my new sort of distro area in the car, and also the original ignition feed to run all the sort of stock electrics and stuff. That will also be ran back inside the car to one side of the isolator switch. The isolator switch will basically cut power to everything other than the alternator and the starter. There's actually a secondary isolator on the battery itself, which then isolates 100% of everything. The reason the isolator doesn't isolate the alternator and the starter, there's two reasons really. There's different ways of doing this. You can get around it with like a double pole isolator, but that's just a single pole one. So the reason behind that is if you put it just on the battery, you can have two problems. One is turning the isolator off there won't actually kill it, because the alternator is obviously energized at that point, and the car will continue to run on the alternator. But more importantly, well, to me anyway, if you basically just suddenly isolate a battery in a system that's up and running, so your alternator is charged and the regulator is happy, and you suddenly take the load of the battery away, you'll find the alternator will spike hugely for a sort of a second as the regulator regains control. So you'll see like sort of 18, 19 or possibly even more volt just for a brief second. And when you've got lots of ECU equipment and expensive electronic stuff being fed off that feed, the last thing you want to do is go and shut that off in an emergency or whatever and shove 18 volt plus through everything, because you'll fry things. So you don't want that happening. So you want the alternator and the battery to always be connected. So you either need a double pole isolator switch, or just have two switches like I do. I've just got two because I already had them, to be honest. Otherwise it would have been better with a double pole. So I'm going to get these leads all connected up where they need to be now, tidied up, and then there's a ground lead that we'll need to put between the engine block and the car, and I also just normally put a smaller one between the cylinder head and the car, just to be 100% sure that we've got a good ground on the two main parts of the engine. Obviously when you've got lots of different things going on, a lot of the sensors and stuff don't actually require ground, but it's always good to have a good ground on the engine for the starter, etc.
You can see on the floor here now we've just got a little loom that I've just made up now. So that's actually just carrying a couple of these sort of standard features which were on the stock loom on the car. So you can see we've got the original Peugeot plug. I was going to put everything on the new plug, and then I figured it's really quite pointless considering all of these little few bits and pieces are right there in the engine bay anyway. So I've just used an original plug and just remade the loom. So it's really just literally like with the reverse sensor for the reverse lights, the speedo drive for the dash. Whether that's going to be retained in the long run I don't know, but for the time being it's just nice and simple to plug that in because it'll just work out the box. The oil pressure light on the dash, I've got that one there, and the alternator energizer, and there's also just a ground cable. So that's really all that's on that loom. I just thought it'd be easier just to make up a separate loom rather than integrate it in the other one, because it's all down around the front of the engine. So that can all just be plugged in now, and then it'll be sort of cable tied and tidied alongside the main loom. Okay, so as you can probably see, we are now mocking up the main engine loom. So this is the engine management side of things. I don't really know how the professionals do this, but this is kind of how I do it. It may not be the best way of going about it, but it works for me, so that's what I do. So when you're making a loom with actual sheathing and heat shrink and everything, you have to start everything connector end and work your way back to the connector, so that you have the right length and everything then ties in as one loom. And now to do that, it's absolutely critical that you get all the wires the right length to start with, or else when you've finished it, obviously things won't reach and it'll look really, really bad. So the way I do it, which seems to work quite well, is basically before you do anything, just set out in your engine bay every single wire that you need to run, just tape it to the connector or tape it to wherever it needs to go with a little bit extra. Run it back to make roughly the route you need to get back to, and then leave excess on the end, which is obviously up in the corner there by the main bulkhead connectors that you can see. So you do that first until you've done sort of all the wires you can think of, and this is also the point where you want to run any spares to any locations in the engine bay where you think you may need extra cables in the future. So maybe over here, where I've got sort of controllers and stuff, I may add some extra cables there, and I'll probably run some extra cables right down the far end of the loom down here. Basically because once you've made the loom properly, it's actually a right pain in the neck trying to add anything to it without basically making a complete hash of it. So it's easier to put extra cables in the loom now, and then you know where they are and you can access them and split out of that later on. So once you've got all of your cables roughly where you need them, what I do then is I'll start bunching them
from the ends again, from the connectors, as I'm going to run them. So you'll just use some masking tape or electrical tape, bunch them roughly as you need, and work your way back, junction at a time, working out where all your joins are going to be, and just keep taping it back until you get it right back, so you've effectively got your loom in position and taped. At that point, you can then, anything which doesn't have plugs or anything associated with it, you can run around all the ends with tape and labels to mark everything up, and then you can then remove the whole thing from the car altogether, lay it out on the floor, and if you want, you can actually draw it on a piece of cardboard, which, if it's quite a complicated loom, makes it a lot easier, because obviously before you can make the loom, you've got to take the whole thing apart again to be able to sheathe it and heat shrink it. So if you've got it drawn on the floor, you know the length of everything, and you can then basically build the new loom to match what you've drawn on the floor. And that's how I do it, and it seems to work. Obviously, if you just want to do it quickly and easily, and I must admit it's what I've done in the past on many vehicles on my own, is to just twist and tape it. So I don't mean twist and tape as in the connections, I mean twist all the wires together roughly where you need them, and then just tape over the whole thing. It's a hell of a lot easier because you can just do it in situ, and if you make a cock up, you can just cut it off quickly and add another wire in and redo it. It works fairly well, but you'll find after sort of 6-12 months it starts looking a bit tacky, and over time the tape dies, and it's all, and if you do need to change it, it's horrible because you end up with loads of tape residue all over everything. It's an acceptable way of doing it, but I'm just trying to do this a little bit more professionally if I can, so we're going to try and do the loom properly. So now that this is all in position, I'm now going to start taping it and bunching everything up to get all the lengths exactly where I need them. Obviously it doesn't matter if you've got lots of length on your tails up by the connector, because that's the very last thing you'll do. So all your wires will just be hanging out the end, and then the very last thing you'll do is terminate it into the bulkhead connector, and at that point you can obviously cut everything to length. So you can see I've got it laid out on the floor now, so I've just marked it all up on some cardboard. So that will then give me all the lengths once I move all the wires out of the way to run all the new cables to the new connectors. Starting to get there now. I've still got a few more wires to run, but that's pretty much the majority of the actual engine loom sort of sensor management side sorted now. So once I've ran the last couple of cables now, I can get this untaped and we can start braiding it all and heat shrinking it all, just leaving the sort of plugs to terminate and all the ends afterwards.
Okay, so you can see I've just finished making up the main engine loom. So we can see I've got all the different connections on there for the various sensors and stuff around the engine. The only last thing to do now is just to actually put the main bulkhead connector on the end, terminate all the wires, and that can then be fitted to the vehicle.
Right, so we're at the last stage of making this loom now. I just need to terminate the sort of multi-pin plug, the bulkhead connector on the end here now. So the most important thing to remember when you're doing this is to slide everything you need on the cable before you start, because once you've terminated 52 wires, you are not going to be wanting to do it again. So in this case, we've got the sleeves and the heat shrinks back here to combine the two looms, which will go over the whole thing. That will go over each loom, and there's another one underneath for that one. And you also need to slide back small heat shrinks on every single wire. Haven't quite finished yet. To put over the pins on the back of the plug as well. So you've got to remember to do that too. So we've got all the smaller gauge wires here. These are 0.5 wires, and then the bigger gauge stuff for some slightly higher ampage stuff, and then the rest are there. And then the shielded cable is actually for the crank sensor. It's actually a reluctor sensor, so a 2-wire reluctor sensor, which is pretty prone to obviously interference, rather than the Hall sensor, which is actually what's on the camshaft. So I'm using a piece of shielded cable for that to hopefully alleviate any problems with interference there. So I'm going to get the rest of these heat shrinks on, and then it's just the boring process of soldering one at a time onto the multi-pin connector, and then we'll commence testing. Right, that's the loom completely finished there now, so we can go ahead and fit that to the car. Basically just put that connector on the end, that's the only difference from before. So we'll go ahead and get that mounted now.